Hi dear students, now I am going to start the 12th standard chapter, that is the solid state. In this video mainly we are going to learn or discuss about the general properties of solids and the classification of solids on basis of packing of constituents in the lattice. The solid state part 1. Let us start this chapter with the general properties of solids. General properties of solids. In the solids, generally the particles are arranged very close to each other. The constituents may be ions or atoms, or they may be molecules. The constituents of solids may be ions or the atoms or the molecules. Right? In the general properties of solids, we know the force of attraction is very high. The force of attraction is very high. Interparticle distance is very low. They are packed like they are very closer to each other. Solids has definite shape and geometry. High mechanical strength, high density, generally diffusion is negligible. In the solids diffusion is negligible. In the solids, diffusion is negligible. But a solid can diffuse into the liquid, that is possible. A solid can diffuse into the gas, that is also possible. But in solids, diffusion is negligible, right? High rigidity, high densities it is covered, right? Generally high melting and boiling points. Students, general properties of solids: the force of attraction is very high, interparticle distance is low, they are very closer to each other, only they can vibrate from their fixed position. Movement of the particles is not allowed. Definite shape and geometry, high mechanical strength, high density. In the solids, diffusion is negligible, high rigidity, high melting point and boiling point. But the movement of particles is restricted or not allowed, but they can vibrate from their fixed positions, right? These are the general properties of solids. Let us discuss about the classification of solids. Students, in the classification of solids, solids can be classified on two bases. Solids can be classified on two bases. One is packing of the particles, other one is force of attraction between the particles, right? In this video, let us complete the first part, that is classification on the basis of arrangement of constituents in lattice. First classification, solids can be classified on two bases. One is based on the arrangement of the particles, second one is based on the force of attraction, right? First classification is classification on basis of arrangement of constituents in lattice. So, based on the arrangement of constituents, solids can be classified into two types. One is crystalline solids, other one is amorphous solids. Directly, let us take the differences between the crystalline solids and amorphous solids. Crystalline solids has long range order. Amorphous solids has short range order. Crystalline solids have sharp melting points. Means if we are started heating or if we are trying to melt a certain solid at a particular temperature, when we are heating at a particular temperature, suddenly it will change us into the liquid state. These have sharp melting points, right? For amorphous solids, diffused melting points. Diffused melting points or melting point is known as melting range. So, in the case of the crystalline solids, when we have started heating a solid, when it reaches a certain temperature, immediately solid will convert into the liquid state. But here it will start converting into the liquid at a particular point at a certain temperature. For example, it has some 60 to 65 range degree Celsius, a particular solid, assume that. If it is amorphous, it starts melting at 60 degree Celsius and completes melting at 65 degree Celsius. That is known as a diffused melting point, right? When cut with a knife, these forms regular and smooth edges. Here amorphous solids cut with the knife forms irregular edges. These are called as anisotropic. Amorphous solids are called as isotropic. Students, here isotropic, anisotropic. Isotropic means there is a regular arrangement of particles is there in the crystalline solids. When we try to measure some of the thermal properties, electrical properties for the crystalline solids, along this direction if you try to measure, you will get some property. If it is a refractive index, we will get some value. some x value. When we try to measure this in this order, we will get a different value. So the electrical or thermal properties or refractive index like properties, when we try to measure in the different directions, for the crystalline solids we will get a different values. That is called as anisotropic. Whereas for the amorphous solids, there is a irregular arrangement, it is present, irregular arrangement. So when we try to measure some properties, electrical, thermal properties or the refractive index along the any direction, any of the direction, if you try to measure, we will get a same value. So that's why these are called as isotropic, right? And crystalline solids are called as true solids. True solids. Crystalline solids are called as true solids. Example, we can take NaCl, diamond, crystalline solids, diamond, boron nitride, silicon carbide, etc. Crystalline solids example, right? For amorphous solids, these known as pseudo solids are supercooled liquids. These are looking like a solids, but these are actually, they are liquids, supercooled liquids. Example, plastic, glass, Teflon, etc. Right? So students, glass is a amorphous solid, that is known as a supercooled liquids, right? In the next class, we will continue our discussion with the next type of classification, that is classification on the basis of force of attraction of constituent particles, right? Thanks for watching.